And when you divide it 3?
250.
250. Got it! Woohoo! Serato can, all that junk.
Yeah.
I love it. It just makes you think. You think about, gotta be continuous, slope from approaching from the left, maybe the slope approaching from the right. Oh, but we got a system of equations here.
Wait, after you got the k equals 8/5,
Then I looked for something easy on the board that had an equation with k and m in it that I could substitute in it. I like this one. 2k equal to what? 3m plus 2. And I took that 8/5 k,
and plugged it in
for k, and then I had to solve m. You got some fractions there, but it wasn't as bad as you think. Yeah.
Now on number 23, what are they asking for?
Let's look at that. A mass on a spring vibrates horizontally on a smooth level surface. Okay. Its velocity at time t is given by, let me write this down, what does it say?
Vt equals to negative t cosine t.
Alright, on. That's velocity. During what time intervals between time equal to 0 seconds and time equal to 6 seconds is the mass moving to the what?
Left.
Left. I said note, a calculator is not necessary, but if you use it, just make sure you put all your answers values accurate to at least 3 decimal places. So we're going to talk about different ways to approach this. Now, here's velocity. The question is, you got to get the interval. When was this thing moving to the what?
Left.
Moving to the left. Is velocity positive or negative? Negative. Outstanding. So to answer this question, we just got to see when the velocity is negative. There's velocity between what time? 0 seconds and 6 seconds. Does everyone agree?
Yeah.
So there's our problem solving approach. We got to figure out when was the object moving to the left. We said that's when velocity is negative. They said only consider 0 to 6 seconds. So we're just going to look to see when is the velocity negative between t equals 0 and t equals 6. Now to do this, one way, you could graph it on your what?
Calculator.
Calculator, if you want. Now if you're like, is there a way to do this without the calculator? Yeah, you just got to know your trig and your, all students take crack stuff and all that junk. You know what I mean? ASTC and what's sign positive, when's sign negative. You know what I'm talking about? Through the 4 quadrants. So we can do it. Which way would you like to do it? Both?
Yeah.
All right, let's start with the calculator. Does the calculator make a decent graph? You got to just go from 0 to 6 on your window. I don't know what that graph looks like, so and I'll talk about how you can do it without a calculator.
So x max is 6.
I like it, x max 6. And I'll come look at people's calculators. I'll make the sketch here. Here, lead. We're just seeing when the velocity, when it's underneath. And we'll play. Now, what mode you got to be in? Degree or radian?
Radian.
And when check your mode, make sure it says radian. Radian mode. Is it working? You in rad mode? Look at mode.
I'm in right now.
So you're in radian mode. Did you make the window 0 to 6? Cool, I'm going to look at yours. I'll put it on the board too. Ooh, that's nice. It went a little there. So it looks like we're going to have to write from here to here and then again from there to there, right? Now how can I trace there? Trace to that, do you know how to do the 0 thing? Or when you're there, second calc. Oh, that's smart. We can just do intersect. Better, man. It's quicker. You run around. If it shoots over here, we'll just put the curve. Yeah, it gets close. All right, we're looking at the graph. I'll make the picture on the board. What do we get? 1.57. And when the graph went like this. So we can see this is 6 seconds. We graphed it on a calculator. it's from here to here, but then we're gonna have to say union from there to there. Okay? I'll shade in. And we're gonna say from here to here, and then again from here to here, because that's when the velocity was underneath. True?
Mhm.
Now, we just did the intersect button with, you could do 0, 0 if you want. We used our calculator. We noticed that number right there was 1.57. Okay? Now, I was wondering if someone wants to use intersect to get that button. That die.
4.71.
4.71. And so how can I write my interval? From 0 to what?
1.57
Union?
4 point whatever to infinity, 6.
Good. I want to cover that. Now, if you're like, hey, can I do this without the calculator? Yep. I'll show you how. Everyone know ASTC? All students what?
Take crack.
Take correct? No one know that? I'll show you. But I want to make sure, Josephine, you're okay with that? That whole way, there's the graph. We're like, oh, yep, from there to there, from there to there, it's moving to the left.
What's this?
Didn't work?
In the middle?
Radio mode.
No, what's?
You know how to use intersect? Let's see. Oh! Negative x, you don't have to put that piecewise part. That's why, so you can just go up here. Just go over here and just delete all this. Yep. Then you do graph. It goes too far, we'll just take the window and go from 0 to 6. That's what we'll do. Well, that's a cool looking graph. Let's just go from 0 to 6. Hey, you can always fix the window, do zoom 6 or put it back to normal. But now you're not, all right, and then we're gonna trace. Do you like intersect or 0? So if I just trace, I'm gonna trace here. I just wanna know that number. One of them's called second calc 0. I have to left bound,
How do you find the intersect? Do you remember about that?
right bound to the right of that.
It's second trace
And then
and then 5.
No,
You do the same
the
thing.
intersect at the point. Like remember x equals to 0? How do you do that? Do you remember?
It's, you keep pressing enter and it gives you 2 coordinates for x and y.
Second trace.
Yeah, and then 5.
Did it work?
And then
Hold on.
keep pressing enter until it gives you x and y.
Second trace. Oh, okay, intersect at 5. Then 5.
Hey everyone,
It should give you something like this.
what's the phrase?
Give all.
0, 0.
All students take what?
Got the graph.
Take correct? Hey, was there another way to this problem? Yeah, first of all, they said time had to be positive, right?
Yeah.
So do you agree with me? I can always assume that this t here has to be positive. Someone follow me? Good, so t's positive. Now it says negative cosine. I just gotta know where's cosine and what's going on here. So if it's a negative in front, you agree, because all trig functions are positive here.
Mhm.
But it's already got a negative here. So you agree that means from here to this number, because it's already got a negative, it would be negative,
Mhm.
right? But then, isn't cosine negative over here?
So it should be positive.
Isn't cosine negative here?
Mhm.
So what would be a negative times a negative, starting right here?
Positive.
Positive, so it'd be positive from here to here. Isn't cosine negative here?
Mhm.
Cosine's negative in here, and a negative times a negative would be positive. It'd stay positive from here to here to here to here to here, and then again here, because cosine's positive here, this velocity would be what, starting at this value?
Negative.
It'd be negative again. So another way I could have written this answer, if you use that, union. That's another one.
3 pi
Cool.
over 2 through 6. Hold on a second. 0. Oh, why it is positive you're asking for.
Yep. Isn't that neat?
Uh-huh.
I just wanted to show it to you. You go, oh yeah, I know these. I know these numbers. I know ASTC. I know when things are positive and negative for cosine. Cool. Awesome. Any others on here? Or any topic you want to read? Chain rule?
Wanna go over the chain rule?
I'll find one. You want a chain rule? I'll find one on here. You got one?
Rates, related rates.
Oh, you want another related rates?
Can you do the cone?
Now, do you want a cone? You want a triangle? You want
Can you do the cone one on there?
on here?
Yeah, the one with the h minus 5.
Let's do it. We found another cone. We'll do that. You got one? Oh, yeah,
Hang
you sure can.
Can we get a circle one too?
Oh, I'll give you a circle. If it's not on here, they're easy to make. You'll find circles easy because just like area, pi r squared. I think there is a circle on there. We're gonna do the cone one. Look at number 20. See it? Let's do the cone one, then we'll do 20. Does that sound good? Hey, before I do that though, what's the area of a circle? Pi r squared. What's the circumference of a circle? 2 pi r. All right. But we're gonna do this cone one. Which problem is the cone one? Which one was it?
I think it's 24.
24. And when this is our typical cone problem, just like the other one, but there was something funny about this problem, how it did a h minus what?
12.
It kind of throws you off.
Yeah.
It throws you off. Always one little thing, you go, what the heck's this h minus 12 thing? So let's read through it. They go, water is draining from a conical tank with height 12 feet and diameter 8. Okay, so we're gonna draw a conical tank. And here, just let it drain, here. Water's draining. Here's your cone. Height's 12 feet. 12. Not drawing a scale there, right? That's 12 feet. Diameter is 8. Anybody know the radius?
4.
Is you okay if I just put 4 of them? I want to make sure everyone's okay with that. Are you okay if I just go right to radius? They said diameter 8, I'm going to make R4. Is everyone okay with that? The reason is I always want to look at the RH relationship. We all know I'm eventually getting to this. We all know I'm eventually getting to this. And so that would be given to you, right? I'd give you that form, but eventually we're getting there. So when they said diameter is 8, I'm just making R what?
4.
By the way, does anybody know what the ratio of R over H already is?
1/3.
1/3.
Is it 1/2?
It's 1/3.
1/3.
Because it's 4 to a what?
4
12.
over 12.
So if you solve for R, what would R equal?
H over 3.
So that's equal to 1/3.
Can't you just memorize that?
Remember last problem though, it was H over 2? Do you remember? It wasn't H over 3 last time.
How did you?
Do you remember? So that's what I mean, it depends on the way they set up those dimensions on that cone. So that's why we can't always say, like last time it was a ratio, radius equal height over 2. Because they said something about the diameter and height were always the same size. Cool. But now I'm just gonna substitute this where?
For R.
Alright, what do you get?
1/3 pi h over 3 square times h.
So it'd be pi h cubed over 27.
Pi h cubed over 3 squared is 9. 9 times 3 is?
27.
I don't want to rush anybody. I'm going to write this again. But that's why we couldn't just memorize that, because it depends on the relationship between R and H.
Can you go between the first, from plugging it into that?
You bet.
Step by step?
You bet. So what I did was, first of all, you saw I put H over 3 there, right? So now, mathematically, let's start by squaring both of those. You would get 1/3 pi h squared over 3 squared. But I know you know 3 squared is 9, right? Cool. Now we have this. So we got that step. But now you have a 9 and a 3 in the denominator. So in our next step, let's multiply the 9 times the 3. That makes 27. And then h squared times h is h cubed. So we finally got V. Hey, you remember what we always do next after this? Because I remember you asked what we do. Differentiate
Mm-hmm.
both sides with respect to t. So this will become a,
dv dt.
DVDT.
and here we do let's do a power rule on that, and then write dH dt, right?
Mm-hmm.
3 goes in front. With that constant, decrease it by,
dh 2 1, yeah.
Times dH over dt.
I wanna rush this, I wanna wait till everyone gets caught up, because some of you may reduce that ratio there. Anybody wanna do something with 3/27?
Yes, 5/9 8 squared.
Just pi square root of 9.
So pi 8 squared over 9. Pi 9 8 squared d8.
I put the 2 in front.
And we are ready to plug stuff in, right?
Mm-hmm.
Amber, you okay with this?
Yeah.
Yeah?
Mhm.
All right, let's see what they got. Let's see what, we're gonna plug stuff in. Usually at this point, everyone, they said, this is 20, this is 10, right? At this moment. Let's see what they got. So we go to this problem and they said this. The depth h in feet of the water in a conical tank is changing at the rate of h minus 12 feet per minute. Okay, let me say that again. The depth h in feet of the water in a conical tank is changing at the rate, that's a rate of change.
Mm-hmm.
They're saying the rate of change of the height with respect to time is h minus 12.
So does
I can replace something in that equation with an h minus 12.
dh dt.
Which one, from there to there, to there to there, something represents, let me read it to you again. The water in the conical is changing, here it comes, changing at the rate of h minus 12 feet per minute. And they said that's the depth
Height
changing,
and-
the height is
height.
changing.